Okay, thank you. I'd like to thank the OMICS group for inviting me to this presentation. My name is Bruno Andrade. I'm from Brazil, the State University of Feira de Santana, State University of Southwest Bahia. And my presentation is exploring pharmacological potential of Brazilian plants, SAM database, a tool for recording and comparison of molecules isolated from plants of Brazilian semi-arid. Oh, something strange. Okay, no problem. The outline is first I'll talk about the semi-arid region, after the Caatinga biome and plant stress and secondary metabolites. And secondary metabolite from Brazilian semi-arid plants, after SAM database, and future developments in SAM. Okay. The Brazilian semi-arid region is a big region of Brazil that comprises 9 states in Brazil and has now 900,000 square kilometers. So this is a big region of Brazil, and it's mainly included in Northwest region, 8% of national territory, and just see it's larger than Texas state of this United States. It is characterized by low rainfall, 500 to 700 millimeters per year. So it's a very dry local. Yes. So this is in yellow is the semi-arid region. So I'm here, Bahia, and almost all the states of Bahia is in semi-arid region. But in this region, the main biome, the main vegetation is called Caatinga, and it's some of different places. So Caatinga is called seasonal dry forest. So where we have Chapada, we have a lot of dry environments. So in this paper, the authors talk about Caatinga as a large geographic area comprised of a variety of different types of vegetation and occupies the largest portions of northwest of Brazil. And the biodiversity study of Caatinga is still growing, but it is small when compared with Amazon and Atlantic forest and Cerrado. So in Caatinga, we have a lot of different plant species and great potential of biodiversity, but we have small studies and we don't know too much about chemicals and from these plants or animals or other kind of organism. So just to see, this is Caatinga, and this can be Caatinga 2, and this situation it is to Caatinga, and this dry, very dry, is to Caatinga. So as you can see, is an environment with different situations, but with very high temperature, UV radiation, and dry soil. So in this other paper, authors talk about the very small studies in Caatinga when we compare with Cerrado, Atlantic Forest, Amazonia Forest, Pantanal, and so Pantanal and Campos is small regions, but the bigger is Amazonia and Atlantic Forest and Cerrado. So Caatinga is one of the smallest regions studied, and so you can see the percentage of papers, and here you can see the relative contribution and of ecosystem and considering research teams and senior researchers, and Caatinga is not too much studies about it. So, as Caatinga is in the semi-arid region, we thought this in this region we will find a lot of different compounds that we just do not find in Amazon and other regions. That is when we have a lot of rain and temperature not too high, and so plants from Caatinga is in great abiotic stress, and it will reflect on the secondary metabolite from of these plants. So in Caatinga and in semi-arid, and we have a high temperature, so and heat and low water draw and high radiation, light and UV radiation. So this will induce the plants to take strategies to defense against these situations and other situations like animals that can eat these plants and other things. So in Caatinga, we have high drought, high temperature, and high light and UV. So as you can see here, we have an long-term and short-term responses considering the situations of high light, high temperature, and low humidity. So signals in root, signals in leaf, signals in all plants. And so we think we find here the increasing of some secondary metabolites and differentiation between these metabolites. Even we have the same species in Caatinga and in Atlantic forest, for example. So 10 years ago, these authors studied about phytochemistry of semi-arid plants, and they found about 2,000 known species, 84 families, and less than 10% have chemical and pharmacological studies. So we have a great potential to study these plants in this region. So we still increasing these studies in phytochemistry and depositing these structures in books and database. So motivation, Brazil's semi-arids, mainly in Caatinga, has a great potential for prospecting new pharmacological compounds, and there was not any database to save and perform in silico studies with these molecules. So we just have public database as PubChem, ZINC, and other database, ChEMBL. So this is a general database, and we find a lot of different compounds with biological activity and no biological activity, but there is no any database to focus in semi-arid regions. So SAN database actually is a web-based Java system which can recall and compare chemical structures. So SAN database is use the same approach like SIA and like ZINC, use the Tanimoto coefficient to compare molecules. So in this tool, we use simplified molecular entry input line entry system, SMILES, for searching. So we put SMILES here and take a search in our database. So we perform search by similarity using Tanimoto coefficient like SIA and ZINC tools. As you know, in Tanimoto coefficient, we have a fingerprint of the bond patterns, like this example, bond pattern 1, bond pattern 2, 3, 4, and we have fingerprint. And with this fingerprint, we compare and generate a number that is the Tanimoto coefficient. So just to see an example, how to use the SAN database, if you want to take a reverse virtual screening, this example of acetaminophen, we can use the canonical smiles of this known drug. So we put this smile in SAN database and take a search. So we found in our database that acetaminophen has some degree of similarity with some compound from Caatinga. So if you want to find if this compound have or not biological activity, we can find it in ChEMBL search. Taking a ChEMBL search, so we have this compound already have probably study biological study, because this is it match in ChEMBL. So we have a match in ChEMBL. But a lot of molecules we have in Caatinga and we have in semi-arid, and when we take a search in ChEMBL, automatically by using SAN, we do not have a match in ChEMBL. So as you can see here, if you use, for example, this other molecule, try ChEMBL again, and no records found. So, and there is no ChEMBL match. Probably there is no biological activity. Probably because maybe someone is studying this molecule and do not deposit it on ChEMBL. But okay. So this is a screen to record the compound. So if you have a compound from semi-arid region, you can put your data here and save in SAN database. So here is some works developed using SAN database in our group. So our focus is in neurodegenerative disease and neglect disease. So we have nootropic improvement using ACH and MDA and R2B receptors. And so we have paper submitted. And research in brain neuroprotective compounds. And with this example is synuclein. And this example is mitochondrial complex 1. Platelet aggregating factors is another work a student is doing. Phospholipase A2, some results. And future improvements, we hope to use a neural network approach to perform molecular similarity and provide Lipinski rules satisfaction to brain studies. So if a molecule is certified or not, Lipinski rules, sorry. And open database to researchers who want to input new molecules. So it's my colleagues and SAN database development, Dr. Valeria, Alex, and student Tiago, brain research, Gedivaldo Lisandro, pharmacology, Wagner, students Michael and Allison, and my colleagues from other university, US, Fabiani and Premio Pirovani. Thank you very much.